Imagine waking tomorrow and finding the sun rising in the wrong place. The North Star no longer fixed above, seasons thrown into chaos, oceans surging where cities once stood. What if this had happened before, long ago, when ancient floods didn't just drown valleys, but shifted the very axis of the Earth? Across the world, myths speak of deluges, waters that swallowed mountains, skies that cracked, nights that lasted forever. To scholars, they are allegories. To survivors, perhaps they were memories. Fragments of a catastrophe so immense it tilted the heavens themselves. Could torrents of water, unleashed at the end of the Ice Age, have tipped our spinning planet off balance? Could the floods that erased civilizations also have rearranged the stars? The thought is staggering. If true, it means our world is not as stable as we believe. It means history itself may rest on hidden convulsions, cycles of water and sky colliding to reset the stage of human life. Tonight, let us step together into that mystery, into the silence where ice, myth, and stone whisper of forgotten worlds. The story of great floods is older than writing itself. Clay tablets from Mesopotamia, papyrus scrolls from Egypt, oral chants from Polynesia, and carved stelae from Central America all repeat the same refrain. There was a time when the waters rose and reshaped the world. Archaeologists and historians have long treated these stories as symbolic, allegories of moral cleansing or seasonal river floods retold on a grand scale. But when one steps back and compares them across cultures, the scale and consistency become difficult to ignore. Nearly every society, regardless of continent or climate, remembers a deluge so immense it wiped away an age of the world. In Mesopotamia, the Epic of Gilgamesh, one of humanity's oldest recorded stories, describes Utnapishtim surviving a flood sent to end human civilization. The waters did not rise for hours or days, but for 6 days and 6 nights, swallowing mountains until all mankind had returned to clay. In India's Shatapatha Brahmana, the sage Manu is warned by a giant fish that a world-destroying flood is coming. He builds a vessel, ties it to the fish, and survives as the waters erase everything else. Among the Maya, the Popol Vuh tells of an age when people were destroyed by floods and the sky itself collapsed. From the Aboriginal peoples of Australia come stories of the drowning of the land, when seas surged inland and forced migrations to higher ground. What is striking is not only the similarities, but the geographic spread. Cultures with no contact, separated by oceans, share the same core elements: rising seas, the erasure of lands, and survivors who carry memory into the next age. Modern science explains this through the melting of Ice Age glaciers, raising sea levels by over 120 meters worldwide. Between roughly 20,000 and 10,000 years ago, coastlines shifted dramatically, drowning continental shelves and erasing vast areas of habitable land. Doggerland in northern Europe, Sunderland in Southeast Asia, and Barinia between Asia and North America were once grasslands and forests. Now they lie beneath the waves. But here lies the radical question: were these floods merely destructive, or could they have been forces large enough to destabilize Earth itself? Water is heavy beyond ordinary comprehension. A cubic kilometre weighs about 1 billion tons. The Laurentide ice sheet, which once covered Canada and parts of the northern United States, held more than 40 million cubic kilometres of ice. When such ice melts rapidly, it does not simply add to ocean volume, it redistributes planetary mass. Satellite measurements today show that as Greenland and Antarctica lose ice, Earth's axis drifts measurably, by centimetres each year. Extrapolate that back to the end of the Ice Age, when meltwater pulses raised sea levels by tens of meters in just centuries, and the forces involved become staggering. The geologic record preserves examples of how sudden these floods could be. The Missoula floods of North America, triggered by the collapse of an ice dam, released up to 2,500 cubic kilometers of water in a matter of days. The floodwaters scoured valleys into canyons, left ripple marks dozens of feet high, and carried boulders the size of houses hundreds of kilometers downstream. If such devastation could happen regionally, what might have occurred when meltwater surged globally? Sea levels did not simply creep upward, they jumped in pulses, most dramatically in Meltwater Pulse 1A, around 14,600 years ago, when seas may have risen 20 meters in less than 5 centuries. For ancient peoples, these events were not abstract data points, they were lived catastrophes. Coastal settlements would have been erased. River valleys, once fertile, would have become drowning traps. Survivors would flee inland or uphill, carrying with them stories of wrathful oceans and collapsing skies. Oral traditions are memories stretched across generations, and when compared, they reveal not only fear of water, but hints of cosmic disorder. The Chinese myth of Nuwa, repairing the broken sky after a great flood, suggests that the catastrophe was not only terrestrial. In Norse traditions, Ragnarok ends with a flood that drowns the world, followed by a new sun in a reordered sky. Even the Inca of the Andes preserved tales of a flood that ended one world age before the rise of their own. These recurring themes invite a deeper question. Did survivors perceive not just floods, but celestial changes? If Earth's axis shifted under the stress of redistributed water, the sun and stars would rise and set in altered positions. Seasonal cycles could change abruptly. To ancient skywatchers, such as those who aligned temples to solstices, this would not have been a subtle difference, but a shattering of cosmic order. The flood then becomes not only water's destruction, but the symbol of the heavens reoriented. Modern science remains cautious. True polar wander, shifts in the geographic poles relative to Earth's axis, is accepted in geology, but it is usually framed in terms of millions of years, not sudden catastrophes. However, the existence of rapid climate reversals, such as the younger Dryas cold event, shows that global systems can flip in decades. If water is capable of shifting Earth's axis even slightly today, it is not unreasonable to ask whether Ice Age floods on a far greater scale could have triggered abrupt changes in Earth's orientation long ago. Thus, the cataclysmic question emerges. Were the great floods remembered by myth and recorded in geology powerful enough to tip the very axis of Earth? It is a question that unsettles because it challenges both science and history. If true, it would mean that our world has been not only reshaped by water, but rebalanced in the heavens by its weight. It would mean that myth is not merely symbolic, but a distorted record of survivors watching a sky that no longer behaved as before. This is where our journey begins, not with certainty, but with a mystery that lies at the meeting point of myth, geology, and planetary mechanics. If the floods of old could move not just rivers, but the axis itself, then the Earth we know today is only one version of a world that has already been tilted and remade. To understand whether floods could influence the balance of Earth, we must first understand what the axis truly is. The Earth rotates once every 24 hours around an imaginary line connecting the geographic North and South poles. This axis is tilted about 23.5 degrees relative to the plane of Earth's orbit around the Sun, an angle responsible for the existence of seasons. Without that tilt, the equator would experience perpetual summer, the poles eternal twilight, and the distribution of ecosystems would be radically different. The tilt is not static. Over tens of thousands of years, the angle oscillates between about 22.1 and 24.5 degrees in a cycle known as obliquity. This slow variation is one of the Milankovitch cycles, identified in the 20th century, which help explain the advance and retreat of ice ages. In addition, Earth wobbles like a spinning top through precession, a 26,000-year cycle that slowly shifts the orientation of the axis relative to the stars. These cycles are gradual and predictable, shaping climate patterns but not causing sudden upheavals. Another phenomenon is true polar wander. Unlike precession or obliquity, which are changes in the tilt relative to the orbital plane, true polar wander describes a reorientation of Earth's solid outer shell relative to its rotation axis. Imagine the planet as a ball with a slightly uneven weight distribution. If a large mass accumulates on one side, say a supervolcano or a massive ice sheet, the planet may slowly adjust its orientation so that this heavy region moves closer to the equator, minimizing energy and stabilizing rotation. Evidence from paleomagnetism, the study of magnetic minerals in rocks, shows that Earth has undergone such reorientations in the past. Geologists point to episodes in the Proterozoic eon, around 800 million years ago, when large-scale polar wander appears to have taken place. Continental reconstructions suggest the crust rotated relative to the spin axis, moving the poles by tens of degrees. More recently, studies of volcanic rocks from Greenland and North America show that in the last 200 million years, Earth has experienced smaller but measurable shifts. While these events occurred on geological timescales, they demonstrate that Earth's axis is not immovable. It can and does change when internal or surface masses are redistributed. The question becomes, what amount of force or redistribution is necessary to cause meaningful axis movement? Scientists studying Earth's moment of inertia, the distribution of mass relative to its axis, explain that even small shifts in mass can have measurable effects. This is observable today. Since the year 2000, satellite data from NASA's GRACE, Gravity Recovery and Climate Experiment mission, has shown that melting ice from Greenland and West Antarctica, combined with groundwater extraction in parts of Asia, has caused the Earth's rotational axis to drift by several centimeters per year. The axis has migrated eastward, a phenomenon directly linked to the movement of water mass across the globe. If the relatively modest ice loss of the past few decades can shift the axis measurably, then the immense floods of the late Pleistocene must have had an even greater impact. During Meltwater Pulse 1a, approximately 14,600 years ago, global sea levels rose by around 20 meters in just a few centuries. This represented the redistribution of roughly 5 million cubic kilometers of water from continental ice sheets into the oceans. The sheer weight of that water, on the order of 5 quadrillion tons, would have altered Earth's mass balance significantly. Whether this caused only minor adjustments or contributed to larger-scale reorientation remains a matter of debate, but the physics supports the plausibility of measurable impact. Another mechanism relevant here is the Chandler wobble. Discovered in the late 19th century by American astronomer Seth Carlo Chandler, it is a small oscillation of Earth's poles with a period of about 433 days. The wobble amounts to a movement of several meters at the poles caused by imperfect balance in Earth's rotation. While small, the Chandler wobble demonstrates the sensitivity of Earth's spin to mass distribution changes. Major earthquakes, for example, can alter it slightly. The 2004 Indian Ocean earthquake, which triggered a devastating tsunami, redistributed enough mass to shift the axis by about 2.3 centimeters and shortened the length of the day by microseconds. These are subtle changes, but they confirm that the system is responsive. Taken together, these observations show that Earth's axis is both stable and vulnerable. Stable, because angular momentum resists sudden, large reorientations. Vulnerable, because redistributions of mass, whether from ice, water, or tectonic activity, can and do shift it measurably. If floods of sufficient scale coincided with other stresses such as mantle convection or crustal weakness, they could have served as the tipping element in larger shifts. Skeptics argue that water, being fluid, quickly redistributes itself, reducing its ability to apply torque compared to rigid ice or rock. While true, the transition itself, from ice on land to water in the sea, represents a rapid redistribution of weight that temporarily unbalances the system. During periods of meltwater pulses, that imbalance was not trivial but global, happening within centuries or even decades. Earth may resist sudden changes, but history shows that even small imbalances, an earthquake, a shifting ice sheet, a melting glacier, can register in its rotation. When the volumes involved are measured not in cubic kilometers, but in millions of cubic kilometers, the idea of water altering the balance of the entire planet no longer seems abstract. It becomes a question of scale, of thresholds crossed, of how much is enough to make the axis sway. Few natural elements carry the paradox of water. It is both gentle and devastating, life-giving and world-erasing. When considering whether ancient floods could have affected Earth's axis, the first step is to evaluate water not in streams and rivers, but in terms of its total mass, momentum, and potential to act as a planetary force. A single cubic kilometre of water weighs 1 billion tons. The global ocean holds approximately 1.35 billion cubic kilometres of water. Most of this volume is stable, locked within the ocean basins, but its distribution is not constant across time. Glacial cycles, tectonic adjustments, and sudden collapses of ice dams have periodically shifted immense amounts of water, redistributing planetary mass. These changes can appear subtle from a human perspective, yet when scaled across continents and centuries, the implications are profound. The Ice Age megafloods provide striking case studies. The Missoula floods of the northwestern United States, occurring between 12,000 and 15,000 years ago, were triggered when ice dams holding back glacial Lake Missoula failed repeatedly. Each outburst released up to 2,500 cubic kilometers of water, an amount equal to half of Lake Michigan, into the Columbia Basin in a matter of days. The water scoured valleys into canyons, left ripple marks visible from space, and deposited boulders weighing hundreds of tons across the landscape. The scale of transformation remains visible today in features such as the channeled scablands of Washington state. Further north, the drainage of Lake Agassiz, a massive proglacial lake larger than all the modern Great Lakes combined, represents an even greater force. Around 8,200 years ago, its sudden release poured thousands of cubic kilometers of water into the North Atlantic. Climate records indicate that this flood disrupted ocean circulation, contributing to abrupt cooling in the northern hemisphere. This episode, known as the 8.2 kiloyear event, shows how a single flood could alter global climate systems within decades. Beyond North America, megafloods have been identified in Central Asia. The Altai floods, generated by the collapse of glacial dams in Siberia, sent torrents across valleys, leaving behind giant gravel bars and massive scoured channels. In the Mediterranean, hypotheses such as the Zanclean flood suggest that around 5 million years ago, the Atlantic Ocean refilled the Mediterranean basin in less than 2 years after the Strait of Gibraltar reopened, delivering water volumes on a scale almost incomprehensible. These examples illustrate that water, when unrestrained, becomes a geologic agent comparable to volcanism or tectonics. Modern analogues confirm the destructive capacity of water on smaller scales. The 1958 Lituya Bay megatsunami in Alaska was caused by a landslide plunging into the fjord, displacing water into a wave 524 meters high, the tallest tsunami ever recorded. Entire forests were stripped from slopes, leaving behind bare rock. While local in extent, the event demonstrates the disproportionate power of sudden water displacement. Similarly, the 2004 Indian Ocean tsunami, generated by a magnitude 9.1 earthquake, moved so much water that scientists measured a 2.3 centimeter shift in Earth's axis and shortened the length of the day by microseconds. Even regional events, when violent enough, leave measurable planetary effects. What distinguishes water from other geologic forces is its mobility. Rock is rigid, ice can fracture, but water flows with both mass and speed. When glacial lakes drain or when ice sheets collapse into the sea, the redistribution of weight is nearly instantaneous. Water surges do not pause for equilibrium. They hammer into basins, rebound, and set new balances. Each surge represents a transfer of energy and momentum across the globe. Hydrologists studying the Missoula floods estimate peak discharges of up to 17 million cubic meters per second, 40 times the flow of the Amazon River. Imagine this not as a regional torrent, but multiplied across continents, driven by collapsing ice sheets at the end of the Pleistocene. Global meltwater pulses such as Meltwater Pulse 1A, around 14,600 years ago, involved sea level rises of 20 meters within centuries. The energy involved in redistributing trillions of tons of water from ice caps to oceans surpasses the energy released by all modern earthquakes combined. If you lived through such a flood, would you see it as natural disaster or as the very earth itself shifting beneath you? Leave your thoughts in the comments and let us wonder together. The cumulative effect of such floods would have extended beyond immediate landscapes. Sudden influxes of fresh water disrupted ocean currents such as the Atlantic meridional overturning circulation, which regulates heat distribution across the planet. Paleoclimate records link these disruptions to abrupt cooling or warming events. The 8.2 kiloyear event and the younger Dryas cooling are both tied to meltwater surges. These are climate consequences, but beneath them lies the mechanical principle: water shifting mass across latitudes, altering Earth's balance ever so slightly. Skeptics point out that while floods change climate and reshape continents, their ability to reorient Earth's axis remains uncertain. The key lies in thresholds. Small redistributions produce small drifts. Massive redistributions, if rapid enough, may cross a line where the crust itself adjusts relative to the spin axis. Today, satellites measure axis drifts of several centimeters per year caused by relatively modest changes in water storage and ice melt. Extrapolating to the megafloods of the late Pleistocene, the possibility arises that their combined effects were sufficient to stress Earth's rotational stability. Cultural memory echoes this scale of destruction. Polynesian oral traditions describe seas running uphill and dragging islands into new positions. Norse sagas tell of oceans overwhelming lands as the world tree trembled. In Chinese chronicles, floods coincide with tales of the heavens slanting to the northwest. These accounts, while poetic, parallel the scientific picture of water not only destroying but redistributing, leaving survivors with skies and horizons altered. Seen in this light, water is not simply an element within Earth's system, but a shaper of that system. It carved canyons, drowned continents, disrupted climates, and at its most extreme, may have pressed the planet itself into new alignment. The Missoula floods demonstrate local devastation. Lake Agassiz shows global climate disruption. Modern tsunamis confirm measurable planetary responses. Together, they establish water as a force capable of bridging the human scale and the planetary scale. The evidence suggests that ancient floods cannot be dismissed as mere metaphors. Their geological imprints, climatic consequences, and cultural memories all point to water as an active, destabilizing force. If floods of sufficient magnitude could alter ocean currents, cool hemispheres, and shift axes by measurable amounts, then it is reasonable to ask whether the deluges remembered in myth and seen in geology were not only disasters, but catalysts for planetary reorientation. During the last ice age, Earth's northern continents carried a weight that defies imagination. Vast ice sheets covered millions of square kilometers. The Laurentide ice sheet stretched across nearly all of present-day Canada and extended into the northern United States. In Eurasia, the Fennoscandian ice sheet spanned from the British Isles through Scandinavia into Russia. Each sheet was several kilometers thick, its frozen mass pressing down on the crust beneath it. Together, these frozen giants locked away enough water to lower global sea levels by over 120 meters compared to today. The physics of such weight are staggering. A single cubic kilometer of ice, though slightly lighter than liquid water, still weighs about 0.9 billion tons. When multiplied by millions of cubic kilometers, the total burden reached tens of millions of gigatons. This mass didn't just freeze landscapes, it warped the planet's crust. Land beneath the ice sheets sank under the pressure, while areas just beyond the margins bulged upward, a process called glacial isostatic adjustment. Earth's lithosphere flexed like a loaded beam, recording in stone the gravity of ice. Eventually, warming began to destabilize these frozen masses. Around 20,000 years ago, the last glacial maximum began to end. Temperatures rose, and ice sheets started retreating. But their collapse was not a slow, uniform melting. Geological and climate records show that the process was punctuated by abrupt episodes of catastrophic ice loss. The clearest example is Meltwater Pulse 1A, about 4,600 years ago. During this event, sea levels rose by roughly 20 meters in less than 5 centuries. That rise required the addition of over 5 million cubic kilometers of water to the oceans, water that had been locked on land as ice. This redistribution was not trivial. Imagine shifting billions of gigatons from high-latitude regions into global oceans closer to the equator. The effect on Earth's moment of inertia, its distribution of mass relative to the axis of rotation, would have been profound. The Younger Dryas period, beginning around 12,800 years ago, adds another layer of mystery. After centuries of warming, the northern hemisphere abruptly plunged back into near-glacial conditions for more than 1,000 years. One leading hypothesis suggests that a massive release of meltwater from the Laurentide ice sheet flooded into the North Atlantic. This influx of fresh water disrupted the Atlantic meridional overturning circulation, a system of currents that distributes heat globally. The climate consequences were immediate. Europe cooled rapidly, ecosystems collapsed, and megafauna populations suffered sudden declines. Some researchers, however, have proposed that this event was triggered or amplified by a cosmic impact or volcanic eruption. Regardless of the cause, it underscores the destabilizing power of rapid ice collapse. The 8.2 kiloyear event provides a more recent parallel. Roughly 8,200 years ago, Lake Agassiz and Lake Ojibwe, massive proglacial lakes covering parts of present-day Canada, drained catastrophically into the Atlantic. Sea levels rose by several meters, and climate patterns shifted within decades. Ice cores from Greenland record sudden cooling, while archaeological evidence suggests that early farming communities in the Near East were disrupted by droughts linked to changing atmospheric circulation. From a mechanical standpoint, these sudden redistributions of water did not simply raise seas, they altered Earth's balance. When ice sheets collapse, mass concentrated near the poles shifts into oceans that lie closer to the equator. This shift in mass pulls Earth slightly off its previous orientation, prompting the axis to adjust. Today, satellite data confirm this principle. Since 2000, melting from Greenland and Antarctica has measurably altered the direction of Earth's rotational drift. Modern changes are measured in centimeters per year, but scaled to the enormous ice collapses of the past, the adjustments could have been far larger. The cultural record may preserve echoes of these events. In Chinese mythology, the goddess Nuwa is said to have repaired the broken heavens after a flood, with the sky tilting to the northwest and the land sinking in the southeast. This is a striking metaphor for an axial adjustment, a world that no longer aligns as it once did. In Mesoamerican traditions, floods are linked with the destruction of world ages and the reordering of the sky. Among the Norse, the end of one cosmic cycle is remembered as a flood that follows the breaking of Yggdrasil, the axis of the world itself. These stories are not precise measurements, but they capture the perception that water and sky once shifted together. The geological record supports the notion that ecosystems experienced sudden, disorienting changes. Fossil pollen from European lake sediments reveals forests collapsing within decades, replaced by tundra vegetation. In Siberia, mammoths and other megafauna perished in conditions that suggest abrupt freezing. Such rapid transitions align with the hypothesis that ice collapses and their ensuing floods caused not only regional climate disruption, but also adjustments to the planet's axis. Skeptics argue that angular momentum, the tendency of a spinning body to resist sudden change, would protect Earth from large reorientations triggered solely by water. While true in principle, it overlooks the scale of mass involved and the possibility of thresholds. Earth's axis does not need to swing dramatically for its effects to be catastrophic. Even small changes in tilt or drift can reconfigure climates, shift rainfall patterns, and redraw coastlines. For ancient peoples living on the edge of ice sheets or in low-lying coastal zones, such changes would have been world-ending. Seen through this lens, the collapse of Ice Age ice sheets becomes more than a story of melting. It is a story of destabilization, of planetary mass being redistributed so suddenly that both climate and orientation were affected. The floods were not simply consequences of warming, they may have been active agents in tipping Earth into new states of balance. When the ice released its weight, Earth itself adjusted. For those alive at the time, the consequences were catastrophic. Lands drowned, climates shifted, skies seemed to move. The memory of these upheavals persisted not in scientific terms, but in mythic language, encoding trauma as tales of tilted heavens and broken worlds. The collapse of ice sheets, therefore, is more than geology. It is one of the clearest mechanisms by which ancient floods could have been linked to axis shifts. Water's weight, once locked as ice at high latitudes, was unleashed across the oceans, forcing Earth to rebalance. In this way, the great floods of the Ice Age may have been not only climactic turning points, but cosmic ones, remembered by survivors as the moment when water and sky together betrayed them. Flood myths are among the most widespread cultural narratives in human history, but often overlooked within them are details that suggest not only rising waters, but disturbances of the sky itself. To early peoples, the heavens were more than background scenery. The positions of the sun, moon, and stars were central to agriculture, navigation, ritual, and the very structure of time. Any sudden disruption to this order, shifts in where stars rose, where the sun set, or how long the seasons lasted, would have been perceived as catastrophic. For this reason, it is important to ask whether the flood stories we inherit might also encode memories of altered celestial order, fragments of what could have been axis shifts remembered as tilted skies. In Mesoamerica, the Aztec tradition of the 5 suns describes successive ages of the world, each ending in cataclysm. The 4th sun ended in a great flood, and survivors were transformed into fish. Yet the myth also records that after the flood, the heavens themselves were remade, inaugurating a new cosmic era. This detail hints at more than inundation. It suggests that after the waters receded, the sky appeared different, as though Earth itself had reoriented. The Norse Eddas recount Ragnarök, the twilight of the gods, where not only floods consume the earth, but the cosmic order collapses. Yggdrasil, the world tree connecting heaven and earth, trembles and breaks. The sun is swallowed, the stars vanish, and the seas overwhelm the land. In the aftermath, a new world emerges, bathed in light from a reborn sun. Scholars often interpret these tales as allegories of cultural collapse and renewal, but they can also be read as memories of skies that no longer match the old patterns, constellations out of place, solstices misaligned, and seasons disrupted. Polynesian oral traditions carry similar imagery. In some Hawaiian chants, the heavens are described as having once pressed so low that humans were forced to crawl. The gods pushed the sky upward, separating it from the earth, but not before floods swept across islands and displaced ancestral lands. These stories blend water with celestial change, as though the two were inseparable in cultural memory. Chinese mythology preserves perhaps the most explicit reference to tilted heavens. The legend of Nua tells how the pillars of the sky collapsed after a great flood, leaving the firmament fractured. She repaired it by using stones of 5 colours, but the heavens remained permanently tilted to the northwest, while Earth sagged in the southeast. Some historians view this as a metaphor for natural disasters and political upheaval, but the imagery corresponds uncannily with what survivors of an axial shift might have observed. The sky no longer aligned as before, and landscapes seemed distorted by water and imbalance. Even within the ancient Near East, where the story of Noah in the Hebrew Bible and Utnapishtim in the Epic of Gilgamesh emphasize water's destruction, there are hints of celestial disruption. In Gilgamesh's account, the storm that brings the flood also blots out the stars for days. The heavens themselves appear unstable. For a society deeply attuned to celestial rhythms for agriculture and religious calendars, such anomalies would have been profoundly unsettling and remembered as part of the catastrophe. Anthropologists studying flood myths across indigenous cultures in the Americas have noted recurring themes of the sky falling, stars being rearranged, or day and night being reversed. Among the Inuit, some stories describe a time when the sun once rose in the west and set in the east. While often dismissed as metaphor, such tales align with the possibility of survivors perceiving the effects of even small axial shifts, altered solar paths, and disordered seasons. Scientific evidence strengthens the plausibility of these accounts as memories rather than pure allegory. Paleoclimatic studies confirm that during the end of the Pleistocene, abrupt changes in climate occurred within decades. Ice core data from Greenland show temperature drops of up to 10 degrees Celsius in less than a century. Fossil pollen reveals entire ecosystems collapsing and being replaced almost instantly. Such changes would have shifted the timing of planting, migrations of animals, and even the apparent order of the sky as viewed against the seasons. Moreover, archaeological evidence shows that ancient cultures were extraordinarily attentive to celestial order. At sites such as Göbekli Tepe in Turkey, dating back over 11,000 years, pillars are aligned with specific constellations and celestial events. In Egypt, temples like Karnak and Abu Simbel were built to capture the sun at solstices with extraordinary precision. In Britain, Stonehenge tracks the midsummer sunrise and midwinter sunset. These alignments prove that ancient peoples would have noticed any irregularities in the heavens. If stars shifted position or solstices fell out of alignment, it would not have gone unrecorded. If floods and axial adjustments coincided, the trauma would have been remembered in layered ways. Water erased lands, displacing communities and reshaping coastlines. The sky, meanwhile, betrayed expectation, breaking cycles that had governed ritual and survival. To encode these shocks, myths turned the flood into divine wrath and the tilted heavens into cosmic collapse. Survivors spoke of gods breaking the pillars of the sky, of suns swallowed and reborn, of skies pressing too close. These were symbolic languages, but rooted in genuine disorientation. Skeptics argue that such myths are simply archetypal, shaped by universal human fears of water and disorder. While this is possible, the consistency across widely separated cultures suggests a deeper common experience. It is unlikely that people in Scandinavia, Polynesia, Mesoamerica, and China all independently invented nearly identical imagery of skies collapsing and waters overwhelming. Far more likely is that these accounts preserve memories of shared global upheavals, refracted through culture and time. Thus, myths may serve as cultural seismographs, recording in metaphor what no stone inscription could capture directly: the perception of a world that tilted. While geology gives us fossils and ice cores, myths give us the human perspective, the confusion of survivors watching not only seas engulf their lands, but stars rearrange themselves overhead. The memory of tilted heavens within flood myths reinforces the idea that deluges were not isolated local events. They were part of larger disruptions that included celestial order itself. And while the language of gods and monsters cloaks these events, the underlying experience is clear. Water and sky betrayed their expected roles, leaving behind stories of worlds destroyed and reborn under a different axis. The Earth itself holds memories that predate myth. Rock layers, coastlines, and fossilized remains serve as silent witnesses to upheavals long forgotten by human history. Among these, certain anomalies stand out: shorelines stranded high above modern seas, marine fossils embedded in mountain ranges, and vast terraces that look like the imprints of vanished oceans. These geological echoes are not only evidence of flooding, they may also hint at sudden reorientation of the planet's balance, events survivors could only have described as tilted skies and broken worlds. Raised shorelines are one of the clearest markers. Along the coasts of Scandinavia, geologists have documented ancient beaches perched hundreds of meters above today's sea level. The mainstream explanation is glacial isostatic rebound. When ice sheets melted, the crust once compressed under their weight slowly rose back upward. This is well established, measurable even today in places like Finland, where land still rises nearly 1 centimetre each year. Yet not all raised shorelines fit neatly into this model. In South America's Andes, marine terraces stand at altitudes that suggest sudden uplift, not just slow rebound. Some of these terraces bear wave-cut notches and fossil shells identical to those found along modern coasts, but now stranded far above the tide. Lake Titicaca, situated nearly 4,000 meters above sea level on the Bolivian-Peruvian Altiplano, offers another striking case. Around its shores lie ancient terraces and fossil remains that indicate water levels once stood hundreds of meters higher. Some archaeologists argue that pre-Inca cultures built ports and temples now lying far from the present shoreline, suggesting rapid changes in water distribution. Could tectonics explain this? Possibly. But another interpretation is that shifts in Earth's orientation altered rainfall and runoff patterns, rebalancing entire watersheds. If the axis moved, precipitation belts might have shifted abruptly, swelling some lakes while draining others. Marine fossils in unexpected places deepen the mystery. In the Himalayas, at elevations above 8,000 meters, geologists have found fossilized ammonites, sea creatures that lived millions of years ago. Mainstream science attributes their presence to plate tectonics. The collision of the Indian and Eurasian plates lifted ancient seafloor into the world's tallest mountains. This explanation is solid, supported by evidence of uplift and ongoing seismic activity. Still, when seen alongside sudden post-ice age changes elsewhere, it raises a broader question. Could some fossil placements, especially those closer to the Holocene, reflect not only tectonics but rapid hydrological or axial changes? North America preserves further clues. In the Great Basin of Nevada and Utah, dry desert valleys are ringed by ancient shorelines, remnants of vast Pleistocene lakes such as Lake Bonneville. At its peak, Lake Bonneville covered more than 50,000 square kilometers. When its natural dam failed around 14,500 years ago, a catastrophic flood carved out the Snake River Canyon. Today, the Bonneville salt flats are all that remain, a flat expanse that once lay beneath deep water. These stranded beaches, carved into mountain slopes, serve as reminders that seas and lakes can surge and retreat with dramatic suddenness. Other anomalies defy easy explanation. In the Sahara Desert, fossil fish and ripple marks testify to an environment once dominated by rivers and lakes. Some of this change is linked to the African humid period, when shifts in monsoon patterns turned deserts green. Yet oral traditions in North Africa also recall floods and tilts, suggesting that shifts in rainfall belts may have been abrupt and disorienting. Geological cores confirm that transitions from lush wetlands to deserts sometimes occurred in just centuries. If even small adjustments in Earth's axis could displace monsoon tracks, then deserts might emerge where seas once fed life. The frozen mammoths of Siberia add another dimension. Their remains are often found in positions suggesting rapid burial. Some carcasses still contain undigested grasses and flowers, indicating they died suddenly in relatively warm conditions before being flash frozen. One interpretation is rapid climate change caused by fresh meltwater flooding the North Atlantic. Another, more radical, is that their grazing grounds shifted abruptly into polar latitudes when Earth's balance tilted. Though debated, the evidence of instantaneous death and preservation underscores the speed with which environmental changes struck. Ripple marks, giant boulders, and erratic deposits add further testimony. In Washington state, the channeled scablands bear ripples up to 15 meters high, carved by the Missoula floods. These ripples are essentially frozen waves, preserved in stone. Across the world, similar features appear in places where no modern flood could account for them. Some scientists interpret these as remnants of glacial outbursts, others as signs of tectonic lake drainage. Yet the scale of these features, valleys scoured bare, basalt canyons carved in days, reminds us that floods leave geological scars large enough to mimic the effects of long ages of erosion. Skeptics argue that every anomaly can be explained by tectonics, erosion, or localized flooding, and often they are correct. Raised shorelines may be rebound, fossils at altitude may be tectonic uplift. Yet when viewed together, these features form a pattern. Terraces high above seas, lakes that swelled and emptied, fossils frozen in wrong climates, deserts hiding ancient rivers, all suggest not just local changes, but systemic upheaval. The most compelling aspect is the abruptness. Shorelines do not climb mountains overnight. Ecosystems do not collapse in decades without major triggers. The geological record repeatedly shows sudden transitions, often aligning with meltwater pulses and rapid climate shifts at the end of the Ice Age. If Earth's axis shifted even slightly during these times, the distribution of water, ice, and climate zones would have reorganized in ways that match the evidence left in stone. Geology and myth, though separated by method, echo one another here. Myths remember skies falling and seas rising, rocks preserved, terraces stranded, fossils misplaced, ripples frozen. Together they tell of a world reordered. Whether by tectonics alone or by tilts triggered by floods, the scars remain etched into Earth's surface. The landforms we see today are not just backdrops to history, they are records of catastrophe. They remind us that Earth's balance has shifted before, and that water, when unleashed, has the capacity to move not only rivers and mountains, but perhaps even the axis around which the world spins. And if this is true, then the regions that should carry the clearest fingerprints are the very anchors of that axis, the poles themselves, where ice, fossils, and ancient maps may preserve the sharpest echoes of Earth's past convulsions. The poles are more than points on a map. They are anchors of Earth's axis, the very ends of the line around which the planet spins. If ancient floods and sudden redistributions of mass really did destabilize that axis, then the clearest evidence should lie here, at the frozen edges of the world. And indeed, both the Arctic and Antarctic preserve mysteries that challenge our assumptions about what these regions have always been. Antarctica, today a desert of ice 2 kilometers thick, is one of the most extreme places on Earth, yet fossil evidence tells a very different story. In 2017, researchers drilling beneath the West Antarctic ice sheet discovered fossilized roots and pollen grains from temperate rainforests, dating back about 90 million years. These finds confirm that Antarctica once supported lush vegetation, with conditions similar to modern New Zealand. Mainstream geology explains this by continental drift. Antarctica was once positioned farther north and slowly drifted southward to its current polar location. But the discovery of tree rings suggesting rapid seasonal cycles also raises questions about whether shifts in tilt, not only tectonics, influenced ancient climates. In the Arctic, similar contradictions appear. On the islands of Svalbard, above the Arctic Circle, paleontologists have unearthed fossils of crocodiles and palm trees, dated to the Eocene epoch, around 50 million years ago. These fossils are evidence that the region once experienced subtropical conditions, despite months of darkness each winter. Some of this can be explained by higher greenhouse gas concentrations at the time, but the degree of warmth still puzzles scientists. Was it simply climate, or did Earth's orientation once place these regions closer to sunlight? The frozen mammoths of Siberia are another enduring puzzle. Tens of thousands of carcasses have been found preserved in permafrost, many with undigested plants still in their stomachs. Radiocarbon dating shows they died between 40,000 and 10,000 years ago, with many extinctions clustering near the end of the Pleistocene. The speed of their burial suggests abrupt freezing, not slow environmental decline. Some hypotheses point to meltwater pulses disrupting ocean currents, while others consider the possibility that a shift in axis abruptly plunged grazing lands into polar night. Which explanation do you find more convincing? Climate disruption, or something even larger like axial tilt? Maps add another layer to the enigma. The Piri Reis map, drawn in 1513 by an Ottoman admiral, famously shows the coasts of South America with surprising accuracy. More controversially, it appears to depict a southern continent resembling Antarctica, not with its current ice cover, but with what looks like an ice-free shoreline. Supporters of alternative history argue that this suggests ancient civilizations mapped Antarctica before it froze, preserving the knowledge until it resurfaced in Renaissance cartography. Mainstream scholars counter that the Antarctica coast may simply be a distorted continuation of South America. Still, the debate highlights a recurring theme: persistent traditions of lands remembered where no land should be visible. Ice cores drilled from both Greenland and Antarctica provide scientific data that complements these mysteries. In Greenland, cores stretching back over 100,000 years reveal sudden shifts in climate, sharp drops and rises in temperature within decades, not millennia. In Antarctica, isotopic records show different pacing, sometimes out of sync with Greenland, suggesting that the poles did not always respond to global events symmetrically. If the axis itself shifted, even slightly, the redistribution of sunlight could explain why polar records appear mismatched at certain times. The Inuit of the Arctic also preserve oral traditions that may echo such upheavals. Some stories describe a time when the sky turned upside down, or when the sun once rose in the west. These may sound like poetic exaggerations, but when compared with geological data pointing to rapid changes in polar conditions, they take on a new resonance. Oral memory often encodes events in metaphor. To a people navigating by the stars, a shift in the heavens would be remembered as a cosmic betrayal. Antarctica conceals yet more puzzles beneath its ice. Radar surveys have revealed subglacial lakes, such as Lake Vostok, sealed off for millions of years. Beneath kilometers of ice, these lakes remain liquid, warmed by geothermal heat and pressure. What secrets lie within them? Unique ecosystems, preserved climates, perhaps even sediments that record rapid axis changes. Scientists continue to probe, but answers remain hidden in the dark. It is also worth noting that both poles are still shifting today. Satellite measurements confirm that melting ice in Greenland is contributing to a measurable drift of the spin axis eastward. Between 1993 and 2010, the axis shifted by more than 10 centimeters per year, small on a human scale, but significant on a planetary one. If such shifts occur with relatively modest modern ice melt, what might have happened when entire ice age sheets collapsed in torrents? Skeptics point out that fossil forests and ancient crocodiles are consistent with known greenhouse climates, and that maps like Piri Reis can be explained by errors in copying and projecting coastlines. But anomalies persist: abrupt freezing of mammoths, mismatched ice core records, and oral traditions of tilted skies. Taken together, these clues suggest that the poles may have been more dynamic and more vulnerable than we assume. The polar regions are not timeless frozen deserts. They are archives of profound change. Fossilized forests, flash-frozen mammoths, ancient maps, and modern satellite data all whisper of instability at Earth's anchors. If the axis has shifted in the past, these are the places that would bear its clearest fingerprints. Yet the poles hold another secret. They are not singular. The magnetic poles wander separately from the geographic poles, drifting and reversing over time. Could this divergence between the compass and the axis offer more evidence that Earth's balance has shifted in ways we barely understand? When most people hear the word pole, they think of a single fixed point at the top and bottom of the Earth. Yet the reality is more complex. Our planet has two very different kinds of poles: geographic poles, which mark the axis of Earth's rotation, and magnetic poles, defined by the orientation of Earth's magnetic field. At times these poles roughly align, but they are not identical. They wander independently, and their divergence tells a story of a planet in motion, one that may help us understand whether catastrophic floods and axial shifts have left their mark. The geographic poles are straightforward. They are fixed by Earth's spin. The North Pole in the Arctic Ocean and the South Pole on the Antarctic continent. These points define latitude, seasons, and the apparent movement of the heavens. In contrast, the magnetic poles are generated by flows in Earth's liquid outer core. Molten iron moving within the core produces a geodynamo, which creates a magnetic field extending outward into space. This is the field that guides compasses, shields Earth from solar wind, and produces auroras near the poles. The magnetic poles are anything but stable. Since their discovery in the early 19th century, scientists have tracked them shifting tens of kilometers per year. The North Magnetic Pole, first located in Canada in 1831, has been racing across the Arctic Ocean towards Siberia in recent decades, moving at nearly 55 kilometers per year. This drift has required frequent updates to navigation models used in aviation, shipping, and even smartphone GPS systems. Over longer timescales, the magnetic poles do more than drift. They reverse entirely. Paleomagnetic studies of iron-rich rocks reveal that Earth's magnetic field has flipped hundreds of times in the past 160 million years. The last major reversal, known as the Brunhes-Matuyama reversal, occurred about 780,000 years ago. During these events, north becomes south, and compasses would point the opposite way. The process can take thousands of years, but during the transition the magnetic field weakens, exposing Earth's surface to higher levels of cosmic radiation. This distinction between geographic and magnetic poles matters for the theory of catastrophic floods and tilts. Geological and mythological records sometimes describe sudden shifts in the heavens or in navigational reference points. Were ancient observers witnessing a physical reorientation of Earth's axis, or were they seeing the effects of magnetic drift or reversal? The two can easily be conflated in cultural memory. For a society navigating by stars, the change of axis would be catastrophic. For one using lodestones or observing auroras, a shifting magnetic field might have seemed like the very sky itself was moving. Paleomagnetic data complicates the picture further. Lava flows, when cooling, lock in the direction of Earth's magnetic field at that time. By sampling such rocks around the world, geologists reconstruct a map of past pole positions. These reconstructions show not only reversals, but also geomagnetic excursions, temporary, partial flips where the field weakened and poles migrated far from their usual positions before snapping back. One of the most famous, the Lachamp excursion about 41,000 years ago, reduced the field's strength to only 5 to 10% of current levels. This event coincided with abrupt climate fluctuations, raising the question of whether weakened shielding from solar radiation amplified environmental stress. Meanwhile, evidence for true polar wander, physical reorientation of the crust relative to the spin axis, exists separately in the geological record. Rocks bearing magnetic minerals sometimes show orientations that cannot be explained solely by magnetic reversals. These may indicate that entire continents once shifted relative to Earth's axis. Some reconstructions suggest that during the late Precambrian, around 800 million years ago, Earth experienced rapid true polar wander of up to 55 degrees in less than 20 million years. While this was not instantaneous, it demonstrates that Earth's orientation can change dramatically under the right conditions. The question then arises, could massive floods during the late Pleistocene have triggered smaller-scale versions of such wander? If trillions of tons of water redistributed from ice sheets toward the equator, the moment of inertia would change. Magnetic records might preserve these shifts indirectly, as changes in how field lines were imprinted in cooling rocks or sediments. At the same time, oral traditions describing the sky falling or the sun rising in the wrong place may conflate both phenomena. A world where magnetic north no longer aligned with geographic north, combined with small but meaningful changes in tilt. Modern measurements provide insight into how sensitive Earth is to redistribution of mass. After the 2004 Indian Ocean earthquake, which generated a tsunami that killed more than 200,000 people, scientists calculated that Earth's axis shifted by about 2.3 centimeters. The day shortened by 6.8 microseconds. These are tiny changes, but they confirm the principle. Moving large amounts of mass alters both rotation and orientation. If one quake can do this, how much more significant would be the melting of ice sheets releasing millions of cubic kilometers of water into the oceans? Skeptics caution against conflating magnetic and geographic phenomena. The magnetic field can flip without any effect on Earth's spin, and true polar wander happens on timescales much longer than human memory. Yet anomalies remain. Some ancient maps show coastlines that suggest knowledge of regions before they were ice-covered, implying either advanced cartography or shifting poles. Ice core records from Greenland and Antarctica sometimes appear out of sync, suggesting changes in sunlight distribution between hemispheres. The possibility lingers that what myths remember as tilted skies may reflect a mixture of experiences: magnetic excursions, climate shocks, and perhaps modest but perceptible shifts in Earth's axis. Understanding the difference between magnetic and geographic poles is crucial to interpreting these mysteries. The compass needle and the starry sky are not the same reference points, yet both have changed across time. Ancient navigators and storytellers may have preserved these changes without distinguishing their causes, leaving us with tales of skies overturned and directions reversed. For scientists today, these stories act as hints, pointing toward the layered dynamics of a planet that is less stable than it seems. The poles, then, are not singular truths, but overlapping mysteries. The geographic poles define the axis of rotation, steady yet vulnerable to redistribution of mass. The magnetic poles trace the restless flows of Earth's core, drifting and flipping in cycles that sometimes coincide with upheavals in climate and life. To mistake one for the other is easy. To recognize their interplay is to see how floods, tilts, and magnetic wander might all contribute to the same haunting memory of a world undone. And if the poles themselves bear witness to such instability, what of the civilizations that lived through it? When waters surged and skies betrayed expectation, it was not only landscapes that shifted, but entire cultures that were torn from their foundations. Beneath the waves and scattered across the continents lie traces of those who stood in the crossfire. Cities drowned, monuments abandoned, and memories reduced to myth. If ancient floods and axial shifts truly convulsed the Earth, the most visible casualties would not have been forests or herds of mammoths, but human communities. Civilizations thrive in stability: stable climates, predictable rivers, reliable stars for navigation and agriculture. When those foundations crumble, so too do the cultures built upon them. Archaeology, submerged ruins, and oral traditions all suggest that human societies once stood directly in the crossfire of global floods and shifting skies. One of the most striking cases is the city of Dwarka, off the coast of Gujarat in India. Submerged structures discovered in the Gulf of Kampat span an area several kilometers wide. Divers and sonar surveys have identified stone walls, steps, and artifacts, some of which have been tentatively dated to around 9,000 years ago, far earlier than the Indus Valley civilization. If the dating holds, this would mean that a complex settlement existed along a shoreline that is now underwater, later drowned as sea levels rose at the end of the Ice Age. Traditional Hindu texts describe Dwarka as the city of Krishna, said to have sunk beneath the sea after his departure. Whether myth or memory, the convergence of legend with archaeological evidence suggests that ancient communities witnessed catastrophic flooding. Further east, the Japanese site of Yonaguni continues to provoke debate. Discovered by divers in the 1980s, the massive stone formations include flat terraces, steps, and apparent road-like features. Some geologists insist these are natural sandstone formations shaped by currents and earthquakes. Others argue the structures show signs of human modification, including right-angled corners and carvings. If Yonaguni was once a human site, it likely stood above water more than 10,000 years ago, before post-glacial sea level rise submerged it. The controversy underscores a key point. Catastrophic floods may have erased entire coastal cultures, leaving only ambiguous traces behind. Closer to Europe, the lost land of Doggerland offers a clearer record. Once a fertile plain connecting Britain to continental Europe, Doggerland supported hunter-gatherer communities for thousands of years. Archaeologists dredging the North Sea have recovered tools, animal bones, and evidence of human habitation. But around 8,200 years ago, the Storegga slide off the coast of Norway triggered a massive tsunami, inundating low-lying areas. Combined with rising seas from melting ice, Doggerland disappeared beneath the waves. For the people living there, the loss was not gradual but catastrophic. Villages swallowed, landscapes gone, forcing survivors into new territories. In South America, legends of a land beneath Lake Titicaca speak of cities drowned by sudden floods. Archaeological dives have found stone structures beneath the lake, some aligned in ways that suggest ceremonial or urban planning. Radiocarbon dating of artifacts points to pre-Inca cultures, though their exact identity remains unclear. If rising waters did submerge settlements here, it would reinforce the idea that ancient communities worldwide faced similar fates, caught between shifting climates and rising seas. The Caribbean also holds stories of sunken lands. Off the coast of Cuba, sonar surveys in 2001 revealed geometric patterns resembling roads and buildings at depths of 600 meters. While studies remain preliminary and highly debated, the possibility of submerged architecture raises questions about how much human history may still lie hidden beneath modern oceans. If even part of these claims prove authentic, they would represent civilizations erased almost entirely from memory, known only through fragments preserved underwater. The crossfire between environment and civilization can also be traced in archaeological transitions. Around 12,000 years ago, hunter-gatherer cultures in the Levant abruptly shifted to farming, laying the foundations for the Neolithic Revolution. While commonly attributed to favorable climates, the timing also coincides with the younger Dryas cold snap and subsequent rapid warming. Floods, droughts, and shifting skies may have forced human groups to adapt radically, accelerating the leap toward organized agriculture and permanent settlements. Similarly, in Mesopotamia, the Sumerians preserved flood stories in the Epic of Gilgamesh. Their legends describe not only destruction but renewal. The flood swept away an old order, clearing the way for new civilizations. Archaeologists excavating sites like Shurapak have found sediment layers that suggest localized flooding, but the myth resonates with larger global patterns. It may encode a memory of survivors who rebuilt in the aftermath of disasters, carrying with them fragments of older, erased cultures. Even in regions far from oceans, legends persist. In North America, Native American tribes recount floods that reshaped rivers and drowned valleys. The Choctaw speak of a time when the Mississippi swelled and buried villages. In the Pacific Northwest, stories of thunderbirds and deluges coincide with geological evidence of massive outburst floods from glacial lakes. Oral traditions, often dismissed as allegory, may in fact preserve eyewitness testimony of real geological events. The pattern is clear. Civilizations rise in moments of relative stability, then collapse or migrate when faced with catastrophic change. Floods at the end of the Ice Age were not gentle tides creeping upward. They were violent surges that destroyed coastlines, drowned fertile valleys, and erased entire cultural landscapes. For survivors, the trauma translated into myths of gods punishing humanity, of worlds overturned, of cities swallowed whole. For archaeologists, the evidence lingers in submerged ruins, abandoned terraces, and sudden cultural transitions. Skeptics remind us that not all submerged ruins are evidence of great civilizations. Some may be natural formations misinterpreted as human. Others may represent small communities rather than global cultures. But the broader pattern cannot be denied. Rising seas between 20,000 and 7,000 years ago permanently reshaped Earth's coastlines, submerging millions of square kilometers of habitable land. Whatever their scale, the societies that lived there were erased from the visible record, leaving only echoes beneath the waves. The idea that these floods coincided with shifts in Earth's axis adds another layer. Imagine communities already reeling from rising seas suddenly finding the stars misaligned, solstices displaced, and weather patterns no longer predictable. For cultures dependent on the heavens for agriculture and navigation, such changes would have felt like the betrayal of the cosmos itself. The flood destroyed their lands, and the sky abandoned its order. Together, these forces left civilizations in ruins, their memories preserved in fragmentary myths and scattered ruins. Civilizations caught in this crossfire did not vanish entirely. Survivors migrated, rebuilt, and adapted. They carried fragments of knowledge into new homelands, creating continuity amid collapse. But the scars of catastrophe remained. Myths of sunken lands, tilted skies, and floods that mark the end of ages are not just stories. They are cultural fossils, preserving experiences that shape the trajectory of human history. Seen in this light, the ruins beneath the seas and the myths of drowned worlds are not anomalies to be explained away. They are central evidence that humanity itself lived through upheavals of planetary scale. Our ancestors were not bystanders to geological change. They were its victims and its chroniclers, recording in myth what stone and sediment confirm. Deep beneath the frozen heart of Greenland, ice lies layered like the pages of a book. Each snowfall, each season, each century leaves its thin mark, compressed into a stratigraphy of time. Scientists drill down and pull up cores, cylinders of ice glimmering with bubbles, tiny prisons of ancient air. Within them lie whispers of temperature, atmosphere, even volcanic ash. But what they reveal most disturbingly are moments of rupture, sudden shifts in climate so abrupt they defy the notion of slow, gradual change. Around 12,800 years ago, the record screams of crisis. In the cores, oxygen isotopes shift sharply, signalling a plunge into cold. What we call the younger Dryas, it was not a gentle descent, but a cliff. Within decades, perhaps even years, the northern hemisphere was thrust back into near-glacial chill. Forests died, grasslands withered, species perished in waves. This was no slow turning of the cosmic wheel. It was an upheaval. And alongside this cold, seas rose and fell erratically, as though the planet itself were rebalancing. Could this be the fingerprint of a tilt, triggered by floods? In Siberia, the mammoths provide another testimony. Some were found frozen so suddenly that undigested plants still lingered in their mouths. They grazed under a mild sky, then perished in an instant, entombed in ice. Theories abound. Sudden climate collapse, comet impact, volcanic catastrophe. But if Earth's axis lurched, shifting a temperate region into the grip of the polar night, such instant freezing might be explained not as mystery, but as consequence. Sediment cores tell a parallel story. At the bottoms of lakes and seas, layers of pollen record vanished landscapes. In one layer, birch and pine dominate. In the next, tundra plants take their place. The transition is not smooth but jagged, as if a climate line had been redrawn overnight. In some places, charcoal layers suggest massive fires raged as forests collapsed. Water and ice reshaped not only coastlines, but ecosystems, scrawling scars into the biosphere. Even stone speaks of floods and shifts. Erratic boulders, perched miles from their origins, tell of waters powerful enough to hurl mountains. Ripple marks, still visible across the channeled scablands of North America, stretch as high as hills, formed by torrents of ice dam collapse. These are the imprints of floods on a planetary scale, reminders that water, when freed, is not gentle but violent. Mainstream interpretations acknowledge these catastrophes but frame them as isolated events, regional floods, abrupt but natural swings in climate. Yet when set beside one another, they form a chorus too resonant to ignore. Ice, fossils, sediments, and stones all record not slow erosion, but sudden convulsion. And when we place them beside the myths of tilted skies and drowned lands, the fragments begin to assemble into a single haunting picture. Floods that shook not only Earth's surface, but its axis. If the frozen mammoth is a witness, if the ice core is a diary, if the ripple-marked canyon is a signature, then altogether they tell us this: the world has ended before, not in fire alone, but in water and tilt, and life has begun again in the shadow of catastrophe. From these echoes of ice and stone, we turn now to echoes of another kind, the echoes of memory carried in the most enduring myth of all, Atlantis, the drowned homeland. In the next part, we will open this ancient riddle anew, not as allegory, but as a possible fragment of the very pole-shifting floods that shattered the old world. Few names stir as much fascination as Atlantis. Since Plato first described it in his dialogues Timaeus and Critias more than 2,300 years ago, Atlantis has haunted imagination, scholarship, and speculation alike. To some it is pure allegory, a parable invented to criticize hubris and warn Athens of moral decay. To others, it is the faint memory of a real civilization erased by catastrophe. And within the framework of floods and possible pole shifts, Atlantis becomes something even more intriguing. Not a single lost city, but a cultural echo of upheavals that reshape the entire planet. Plato's account is clear in its essentials. Atlantis, he wrote, was a vast island empire located beyond the Pillars of Heracles in the Strait of Gibraltar. It was wealthy, technologically advanced, and ambitious, but its people grew arrogant, waged wars of conquest, and were punished by the gods. In a single day and night of misfortune, the island was swallowed by the sea and vanished from history. He dated the event to about 9,000 years before Solon, the Athenian statesman who supposedly brought the tale back from Egypt, placing the destruction of Atlantis around 11,600 years ago. That date is startling. It coincides almost exactly with the end of the Younger Dryas, the abrupt cold snap that lasted from about 12,800 to 11,600 years ago. This was a time of extraordinary upheaval. Ice sheets collapsed, sea levels surged, megafauna vanished, and human cultures were forced to adapt to new conditions. Meltwater Pulse 1b, a major sea level rise event, occurred in this same window. For researchers exploring connections between myth and climate, the alignment is more than coincidence. Plato's story may have been a distant echo of these real-world cataclysms. Archaeological evidence, though controversial, adds weight to the possibility. Submerged structures off the coasts of India, Dwarka, Japan, Yonaguni, and the Mediterranean, Pavlopetri in Greece, Heraklion in Egypt, show that human settlements have indeed been lost to rising seas. None can be identified directly as Atlantis, but together they demonstrate that advanced societies can vanish beneath the waves, leaving behind only myths and fragmentary ruins. Plato may have consolidated many such memories into one narrative, giving the catastrophe a single name: Atlantis. Geological anomalies also play a role. Studies of submerged terraces, abrupt shifts in sedimentation, and drowned river valleys all point to rapid sea level changes during the late Pleistocene. In the Caribbean, submerged coastal shelves drop suddenly into the deep ocean, where sonar has revealed formations that some interpret as step-like platforms. While mainstream geology attributes these to natural erosion, the possibility remains that some features were once above water, only to be lost when seas rose rapidly. Beyond physical evidence, Atlantis resonates because it mirrors myths from around the world. The Maya spoke of Aztlan, a homeland destroyed by floods. Tamil traditions describe Kumari Kandam, a vast landmass south of India swallowed by the ocean. Polynesian chants recall Hawaii, a drowned ancestral island. Each story reflects cultural trauma tied to disappearing lands. When placed alongside Plato's tale, these myths suggest not isolated fables, but fragments of a global memory. The Atlantis story also ties into the theme of skies disrupted. In Critias, Plato describes how Atlantis was aligned with temples, canals, and palaces built in a circular plan. Some researchers have speculated that these circles mirrored celestial order, echoing the heavens in stone. If floods coincided with axial adjustments, survivors may have experienced not only the drowning of land, but the collapse of a cosmic system, where once ordered skies no longer matched their monuments. Skeptics counter that Plato's account contains inconsistencies. He never finished Critias, leaving the story incomplete. The location beyond the Pillars of Heracles could mean the Atlantic, but some argue it referred to regions within the Mediterranean. The supposed scale of Atlantis, larger than Libya and Asia combined, sounds implausible. Many scholars believe Plato intended the tale as allegory, not history. Yet even as allegory, it is striking that his chosen date aligns with real climatic upheavals confirmed by modern science. Modern fascination with Atlantis intensified in the 19th and 20th centuries, as discoveries of Troy, once thought purely mythical, raised hopes that Atlantis too might be real. Writers such as Ignatius Donnelly popularized the idea of Atlantis as the mother civilization, seeding Egypt, Mesopotamia, and the Americas before its destruction. While mainstream archaeology rejects this diffusionist model, the persistence of the idea underscores how Atlantis has become shorthand for the possibility of advanced pre-Ice Age cultures erased from history. The scientific lens invites a different reading. Atlantis need not be a literal island larger than continents. It could be a symbolic memory of all the coastlines and settlements lost to Meltwater Pulse 1b. Imagine communities from the Aegean to the Caribbean watching their ports vanish under rising seas, their maps made useless, their temples misaligned with the stars. For Plato's Egyptian informants, such scattered stories could have merged into a single tale of a once great island empire destroyed by divine waters. The Atlantis connection, then, is not about proving or disproving the existence of a single city. It is about recognizing the possibility that myths encode genuine memories of global catastrophe. Plato's timeline matches real events, his imagery matches cross-cultural flood narratives, and the archaeological record confirms that human settlements were drowned worldwide. Atlantis may be less a place than a symbol, a name for the lost world before the axis shifted and seas surged. And this symbol carries a warning. Plato emphasized that Atlantis fell not only because of nature, but because of human arrogance. Its people, he wrote, grew filled with avarice and unrighteous power. Whether allegory or memory, the moral is clear. Civilizations are fragile, and when the earth itself convulses, even the greatest cultures can vanish in a night. Perhaps that is why Atlantis endures. It embodies both the allure of a forgotten golden age and the terror of sudden destruction. It bridges geology and mythology, science and story, and when placed in the context of ancient floods and pole shifts, it becomes more than legend. It becomes a key to understanding how human memory and planetary change intertwine. To step into the halls of modern geology and suggest that ancient floods tipped the Earth on its axis is to invite raised eyebrows. The theory challenges the bedrock of scientific reasoning: conservation of angular momentum, the stability of Earth's spin, the immense scale of forces required. For many, it belongs not to physics, but to legend. And yet, anomalies remain. Anomalies stubborn enough that the theory lingers at the margins, a ghost in the library of science. Angular momentum is a guardian. A spinning planet resists sudden change, just as a gyroscope holds steady no matter how one tries to tilt it. To alter Earth's axis even slightly requires an unimaginable redistribution of mass, something greater than any floodwaters we can conceive. Critics argue that water, no matter how vast, is still too fluid, too quick to settle, to apply lasting torque. Glacial melt, they concede, shifts weight, but its effect is measured in centimeters per year, not degrees overnight. And yet, in quiet corners of paleoclimate research, questions whisper. Why did the younger Dryas begin so abruptly? Why did climates flip in decades? forests replaced by tundra almost instantly? Why do mammoths lie frozen with food in their mouths, as if warmth had turned to polar night without warning? Mainstream science leans on explanations: meltwater disrupting ocean currents, comet fragments igniting firestorms, volcanic aerosols darkening skies. But each answer opens new puzzles. True Polar Wander 2 complicates the picture. Geologists acknowledge that Earth's crust has shifted relative to its axis in the past. Rocks on different continents, when aligned for tectonic drift, still reveal pole positions far from today's. While these shifts are thought to unfold over millions of years, the possibility of more abrupt movements has not been fully dismissed. Could the cataclysms of the late Ice Age represent moments when Wander accelerated, nudged by sudden imbalances? Skeptics remind us that extraordinary claims demand extraordinary evidence. The raised shorelines, the submerged ruins, the magnetic anomalies, all can be explained without invoking floods tilting the axis. And yet, no single explanation ties them all together neatly. Instead, we are left with fragments, each accounted for in isolation, but together suggesting a pattern. Perhaps this is why the theory endures in the borderlands of science. It is controversial, even ridiculed, but also compelling, because it dares to ask a question science itself sometimes avoids. What if catastrophe, not gradualism, has been the true engine of Earth's history? What if memory of these catastrophes has survived not only in rocks and ice, but in myth? In this way, skepticism itself becomes part of the story. Science holds to rigor, and rightly so, but the persistence of anomalies invites imagination. The axis may never have lurched as violently as myth suggests, but something did happen. Something that scarred landscapes, drowned coasts, and tilted memory itself. So the debate continues, between those who see floods as local tragedies and those who suspect they were planetary events. Between angular momentum's steady guard and the fragility of balance under sudden weight, between skepticism and wonder. And perhaps the most unsettling question is not whether it happened once, but whether it could happen again. For patterns repeat. Ice accumulates, melts, redistributes. Floods rise, climates shift. If axis and water are bound in a cycle, then what drowned civilizations long ago may not be finished with us. In the next part, we will search for those patterns, cycles written into sediment and myth alike. Do pole shifts follow a rhythm? Are floods not random, but woven into the deep pulse of Earth? If so, then the question is not only, did it happen, but when will it return? When considering whether ancient floods and axis shifts shaped human history, it is not enough to look at singular catastrophes. What emerges from both science and myth is the sense of repetition, cycles of destruction and renewal, upheaval and calm. The Earth itself pulses through rhythms of ice and melt, heat and cold, flood and drought. Civilizations rise within stable interludes, then collapse when the pattern turns. To see these patterns across time is to understand that catastrophe is not exception but recurrence. Astronomical cycles provide the broadest framework. The Serbian mathematician Milutin Milankovic showed in the early 20th century that Earth's climate is governed by orbital variations. These include changes in eccentricity, the shape of Earth's orbit around the Sun, obliquity, the tilt of Earth's axis, and precession, the slow wobble of that axis. Together, these cycles operate on timescales of tens to hundreds of thousands of years, pacing the advance and retreat of ice ages. For example, when the tilt of Earth's axis is greater, summers are hotter and winters colder, encouraging ice sheets to retreat. When tilt decreases, summers are cooler, ice accumulates, and glacial periods advance. These cycles are gradual, but when amplified by feedbacks, such as melting ice sheets or shifting ocean currents, they can lead to sudden tipping points. The geological record preserves these rhythms. In marine sediments, alternating layers of clay and carbonate align with Milankovic cycles. In ice cores from Greenland and Antarctica, Isotopic data reveal abrupt warmings and coolings that repeat in a quasi-cyclic fashion. One striking pattern is the Dansgaard-Oeschger events, named after the Danish scientists who first identified them. These events are characterized by rapid temperature increases of up to 10 deg within decades, followed by slower cooling. They occurred roughly every 1500 years during the last glacial period. While their exact trigger remains debated, many scientists believe they are linked to disruptions in ocean circulation caused by meltwater surges. Another long-term rhythm is the Bond events, identified in North Atlantic sediments by marine geologist Gerard Bond. These events, occurring roughly every 1,000 to 1,500 years, are marked by increased ice-rafted debris, stones carried by glaciers and dropped into the ocean as icebergs melted. Bond events align with periods of significant climate stress, including the Little Ice Age between the 14th and 19th centuries. If meltwater pulses and axis sensitivity are part of the same system, Bond events may represent moments when the balance of mass and rotation came under strain. Mythology echoes these patterns with uncanny consistency. In Hindu cosmology, the yugas represent vast cycles of ages, each ending in destruction by flood, fire, or darkness before renewal begins. The Aztec tradition of the five suns describes successive worlds, each destroyed and replaced by another. Norse myths envision repeated cycles of Ragnarok in which gods perish, the world is flooded, and a new order arises. Even the Bible suggests recurrence. As it was in the days of Noah, so shall it be also in the days of the Son of Man. Such stories may reflect not isolated events, but recognition of cyclical catastrophe woven into cultural memory. Archaeology hints at recurring collapses aligned with environmental cycles. Around 2200 BCE, a severe aridification event contributed to the decline of Egypt's Old Kingdom, Mesopotamia's Akkadian Empire, and the Indus Valley Civilization. This 4.2 kiloyear event appears in sediment cores as a sudden spike in dust deposits and in cave records as reduced monsoon rainfall. Similarly, the Late Bronze Age collapse around 1200 BCE coincided with widespread droughts and seismic activity, destabilizing civilizations from Greece to Egypt. While not global floods, these collapses illustrate how recurring climatic shifts repeatedly reshaped human history. Even in more recent times, cycles leave their mark. The medieval warm period, circa 900 and 1300 CE, brought expansion of agriculture and population growth in Europe, while the subsequent Little Ice Age, c. 1300–1850 CE, saw famines, plagues, and social upheaval. These swings, though smaller than Ice Age cataclysms, follow the same principle. Human societies flourish or falter depending on where they fall within natural rhythms. The possibility that floods and axis shifts are woven into these cycles deepens the story. If true polar wonder accelerates during periods of mass redistribution, such as during major meltwater pulses, then catastrophic events may not be random but periodic. Earth may carry within it a tendency toward instability at regular intervals, triggered when orbital cycles, ice accumulation, and ocean dynamics converge. This perspective reframes myths of world ages as more than allegory. They may encode recognition of these recurring thresholds. The ancients, observing stars, seasons, and floods over generations, may have perceived a pattern of destruction and renewal. Their response was to build cosmologies that explain these rhythms as divine cycles. In doing so, they preserved a warning that the world is not stable and that collapse is always closer than it appears. Modern science, while more cautious, acknowledges the cyclic nature of climate and catastrophe. The paleoclimate record confirms abrupt swings at intervals. Orbital models predict future ice ages, delayed now by anthropogenic warming, but inevitable in deep time. Even the drift of Earth's axis today, measured by satellites at centimeters per year, reminds us that the planet is constantly adjusting its balance. To see patterns across time is to recognize that humanity lives within cycles larger than itself. Civilizations are not exceptions but participants, rising in warm, stable phases and struggling in colder, wetter, or drier ones. Floods are not merely local tragedies, they are part of recurring surges that have shaped coastlines and cultures again and again. Myths of tilted skies, drowned lands, and reborn worlds mirror what geology and astronomy now confirm, that catastrophe is periodic, not singular. If ancient peoples carried these rhythms in story, perhaps it was their way of preparing descendants for what science now measures. The cycles have not ended. They continue, ticking forward beneath our feet and above our heads. To recognize them is not to predict exact futures, but to understand that upheaval is written into Earth's heartbeat, waiting for the next pulse. Imagine standing at Göbekli Tepe, among pillars carved 12,000 years ago, older than cities, older even than agriculture. The stones rise in circles, aligned with stars. Animals are etched into their surfaces. Foxes, vultures, serpents, symbols that seem to speak of sky and earth, life and death. Archaeologists call it the world's first temple. But what if it is also a message? A portal of memory, encoding not only ritual but remembrance of catastrophe. Floods that rose, skies that shifted, the axis itself unsettled. Across the ancient world, monuments act as memory devices. The Egyptians built temples aligned precisely with solstices and stars. Karnak greets the sunrise of the summer solstice. Abu Simbel channels the equinox sun deep into its sanctuaries. To us, these are feats of architecture. To them, perhaps, they were anchors, ways to track the heavens, to notice if the sky began to drift. If constellations no longer aligned, if solstices no longer fell true, then something in the cosmic order had broken. The Mayans, too, carved calendars into stone, measuring cycles not of years but of ages. Their long count calendar spans thousands of years, mapping not only harvests and rituals but cosmic resets. In their myths, each age ended in water, fire, or darkness, echoes of floods and tilts remembered across generations. Stone became a vault against forgetting. Even in the megaliths of Europe, Stonehenge, Newgrange, Karnak, the alignments speak of more than agriculture. Newgrange channels the midwinter sun into its chamber only once a year. If the sun shifted from that alignment, the people would have known. Was this not merely ceremony, but surveillance, a way of guarding against the return of catastrophe? In Polynesia, chants preserved knowledge of star paths, guiding canoes across oceans. But within those chants, some lines recall skies rearranged, constellations out of place. Oral tradition, like stone, becomes a portal of memory, carrying forward the shock of upheaval. What unites these monuments and myths is not only reverence, but vigilance. They seem to whisper, watch the sky, mark the water, remember the last time the world fell apart. If floods and tilts erased civilizations before, then memory itself had to be anchored in stone and story, lest it vanish again. Perhaps this is why myths so often carry dual tones. Awe for the gods and fear of their wrath. The gods are not distant. They are water, fire, axis, sky. To honor them is to acknowledge their power, to remember their last visitation. If we read these portals of memory not as superstition, but as encoded warnings, a different picture emerges. Ancient peoples were not ignorant. They were survivors. They left us records not only of who they were, but of what had happened. The floods, the tilts, the skies turned upside down, and so we return to the threshold. The monuments stand, the myths persist, the evidence accumulates, yet the riddle is not solved. Science remains skeptical, myth remains poetic, geology remains fragmented. What we are left with is a question that refuses to close, a riddle unanswered. In the final part, we will slow our pace, returning to reflection. We will ask what it means to live on a planet that may tilt again, to carry myths of floods in our blood, to stand at the edge of mystery with no final answer, and perhaps in that silence we will glimpse why the ancients chose not certainty but story. The ocean is still tonight as though it remembers. Waves break softly on shores that were once mountains, once plains, once homes. The stars gleam in their familiar courses, yet in the depths of memory they may not always have stood so. Myths whisper of skies overturned, of floods that reset the world. Stones carved by vanished hands align to solstices as if guarding against a shifting heaven. Ice cores, fossils and ruins murmur of sudden change. And yet the riddle remains unanswered. Did ancient floods truly trigger pole shifts? Science urges caution. The forces required seem too great, the mechanics too improbable. Angular momentum is steadfast, the Earth a gyroscope resistant to sudden tilts. Mainstream explanations suffice if narrowly. Tectonic uplift, glacial rebound, orbital cycles. But the anomalies persist. Forests under ice, mammoths frozen mid-breath, shorelines raised high above seas, cultures remembering water and sky breaking together. Perhaps the truth lies between extremes. Floods alone may not topple the axis, yet in concert with other stresses, mantle currents, ice collapse, even cosmic impact, they might be the catalyst that nudges a fragile balance into convulsion. Catastrophe is rarely simple. It is the sum of forces converging, each one magnifying the others until the world can no longer hold. For the ancients there was no debate. They saw waters rise, skies tilt, homelands drown. They preserved memory not in equations but in myth, not in journals but in chants, temples and stories. To them the axis was not an abstraction but the very order of existence, and when it faltered it was the gods themselves falling. To us the memory comes fractured, doubted, veiled in allegory. Yet it persists, like ruins glimpsed beneath waves, like constellations glimpsed through mist. And so we end where we began, with water and axis entwined. The floods were not merely destruction, not merely punishment. They were thresholds, portals, through which one age ended and another began. To stand at that threshold is to feel the fragility of the world we take for granted, that the ground beneath our feet, the sky above our heads, may be more mutable than we imagine. What if the myths are right? What if the scientists are right? What if both in their own ways are grasping at a truth too immense to be fully known? Perhaps the point is not to solve the riddle, but to remember it, to hold it, as the ancients did, in awe and humility. And if it happened once, could it happen again? The ice sheets melt, seas rise, climates shift, and the axis itself drifts ever so slightly year by year. The rhythm continues. We are not outside of it. We are inside its cycle, living in the brief interlude between upheavals. So let us listen to the echoes, the myths of tilted skies, the stones aligned to solstices, the ice that records abrupt winters, the ruins beneath the waves. They may be fragments of a story that is not finished, a story still unfolding. If floods once tipped the earth, then memory is all that remains, and perhaps all that prepares us. For the ocean is restless, the ice recedes, the balance wavers. And in that silence we feel the weight of the unanswered riddle. Where are you listening from tonight, and at what time? If these stories call to you, consider subscribing, and join me again as we continue to wander the forgotten worlds where myth and science meet.